Tosiaan olen Peltolan Sanna Suomen pakkaustuottajista ja toimin täällä operatiivisena päällikkönä ja vastuulla materiaaleista sitten muovia, kuitupakkaukset ja käydään hiukan läpi vähän perusasioita muovipakkaukset talteenotosta, ehkä pikkusen ekomodulaatiosta ja sitten lasketaan Rickard asiantuntijana tulille, niin laita Eija, kiitos eteenpäin. Tässä tuttua kuvaa aikaisemmista webinaareista. Nyt hiukan on muokannut tätä muoveihin sopivaksi. Tässä ehkä hiukan eroa siitä, että miten materiaali meille tulee järjestelmään. Eli markkinoille saatetaan pommeina noin 123 000 tonnia muovipakkauksia ja iso osa siitä on sitten kuluttajamuovipakkauksia ja tuosta prosenteista näkyykin, että lähes 70% meidän pakkauksista tulee kotitalouksista. Ja sitten teollisuuteen ja kauppaan jää noin 30%. Eli iso osa tulee sitten meidän kaikkien laitteluinnokkuuden kautta tuonne meidän keräyspisteille. Rinki hoitaa meillä ekopistekeräystä. Meillä on tällä hetkellä noin 1200 ekopistettä, missä on muovipakkausten keräys. Tavoite, tai meidän velvoitehan on 1000 pistettä, mutta me on haluttu sit laajentaa vapaaehtoisesti sitä, jotta sitten kuluttajilla olisi laajemmat mahdollisuudet palauttaa sitä materiaalia myös ekopisteissä. Iso osa materiaalista tulee sitten kiinteistökeräyksen kautta. Sehän meillä tutusti hoituu kuntien kautta. Kunnat tekee sitä meidän kanssa yhteistyössä ja sitten samoin materiaali tulee yhtä lailla sitten yhteisiin terminaaleihin, mihin tuo ekopistemateriaali tulee. Terminaalit luonnollisesti on meidän yhteistyökumppaneiden kautta järjestettyjä. Siellä materiaali tarkastetaan, kun se saapuu sinne terminaaliin, katsotaan, onko se laitteluohjeistuksen mukaista. Tämä prosessi on ihan sama sitten, onko sitten ekopiste tai kiinteistö tai onko sitten näitä yrityksien tuomia pakkauksia. Prosessi on sama, laitteluohjeet katsotaan ja sitten jos huomataan jotain sinne kuulumatonta, niin se poistetaan, tai sitten jos on käynyt niin, että erä on jostain syystä hyvinkin reektipitoinen, tai siellä on vaikka sekajätettä tai jotain muuta, niin sitten se napataan pois sivuun ja käsitellään erillisen ohjeistuksen mukaisesti. Mutta pääsääntöisesti kuormat on ollut sitä, mitä pitääkin, ja se on hieno juttu. Tämän jälkeen laitos sitten paalaa muovipakkaukset, pitää erillään kuluttajamuovipakkaukset sekä yrityspakkaukset, koska ne toimitetaan eri paikkoihin. Siellä ne varastoidaan odottamaan sitten meidän noutoa. Eli sitten siinä kohtaa taas me astutaan mukaan hommaan. Me järjestetään paalien nouto sitten ja ne toimitetaan sitten meidän kierrättäjille. Meillähän on tällä hetkellä kierrättäjänä Svensk Plaståtervinning Ruotsissa Muutalassa, mistä Rickard kohta kertoo lisää. Sinne menee ehkä noin puolet meidän pakkauksista, kuluttajapakkauksista. Ja sitten meillä on Remeo yhteistyössä kotimaassa ja ollaan myös käytetty NG:täkin ja tänä vuonnakin tullaan heitä käyttämään, eli kotimaassa sitten pari toimijaa meillä. Ja sitten se jatkuu tietysti heidän laittelun kautta sitten kierrätykseen heidän kumppaneille. Tämä on se prosessi ja se on molemmissa samanlainen. Se mikä ehkä sitten tuossa teollisuuden ja kaupan puolella siellä on myös yrityspakkauksia, mitkä on erilliskerättynä semmoinen, eli vaikka kalvoja. Kalvot menevät sitten suoraan heidän yhteistyökumppaneiden kautta kierrätykseen ja me sitten tehdään näiden käsittelijöiden ja keräjien kautta yhteistyötä ja he ilmoittaa meille sitten näitä tietoja ja sitä kautta myös ne yritysten erilliskerätyt pakkaukset saadaan tilastointiin meille mukaan. Meillä on nyt ollut muutaman vuoden myös tarjolla yrityksille tällainen yhteiskerätyt yritysmuovipakkaukset, vähän samantyyppinen kuin toi ekopistekeräys, eli saa laittaa kaikki yritysten muovipakkaukset samaan kippoon ja sieltä ne sitten jätehuoltoyhtiöt toimittaa meidän terminaaliin ja prosessi on sitten ihan samanlainen, eli paalataan ja käsitellään, mutta täällä on pyritty sitten lisäämään sitä mahdollisuutta myös pienemmille toimijoille kerätä niitä yrityspakkauksia, saada ne talteen ja tämä on kaikille yhtä lailla avoin ja se materiaalin käsittely on maksutonta. Teollisuus ja kauppa maksaa kuljetukset ja astiat ja me hoidetaan loppuun siitä sitten, kun se tulee meidän terminaaliin. Eli tämmöinen on tämä prosessi ja laitatko eteenpäin, sinne tulee yläkulmaan, että tällä sitten katetaan tämä kierrätysmaksu ja tämä koko lysti. Tietysti tähän kuuluu myös lisäksi sitten neuvontaa, mitä Rinki tekee kuluttajille ja sitten meidän yritysneuvonnat ja kaikki muukin, mutta lähtökohta se, miten materiaali pyörii tässä järjestelmässä on kuvattu tässä näin silleen pähkinänkuoressa. Hyvä, mennään eteenpäin. Katsotaan vähän ekomodulaatioluokkia, eli nämä on yhtä kuin myös kierrätysmaksuluokat meillä. 25, eli tämänhetkiset näkyy tuossa vasemmalla. Meillä on tänä vuonna vielä 5 luokkaa. Siinä on määritelty sitten materiaali, mikä kuuluu tai minkä tyyppinen pakkaus on tuossa muovissa, niin aina luokittain A, B, C, D ja E luokat kuluttajapakkauksille omat hinnoittelut ja yrityspakkauksille oma hinnoittelu, mutta niin kuin luokittelu sitten sama. Ja tällä ekomodulaatiollahan on tarkoitus edistää sitä pakkauksen kierrätettävyyttä. Et silloin kun on monomuovipakkaus, se on kaikista helpoin kierrätettävä, niin se on myös sitten hinnaltaankin edullisempi. Ja sitten mitä niin kuin monimutkaisempi tai heikosti kierrätettävä tai jopa kierrätyskelvoton, niitäkin valitettavasti vielä on, niin sitten se luokka aina heikkenee ja sitä kautta myös hinta nousee. Ensi vuonna sitten 2006 me ollaan muutettu luokittelua. Meillä on vain luokkia A, B ja C. Tässä osittain taustalla tietysti se, että PPWR on tulossa sieltä hyvää vauhtia ja siellä sitten luokittelu menee A, B ja C-luokkien mukaan alkuun ja sitten jossain vaiheessa A ja B-luokka on enää hyväksyttävä, niin ollaan menty tähän suuntaan tehty tällainen kevyt muutos ja nyt sitten tietysti odotellaan, että niitä säädöksiä ja tarkentavia ohjeistuksia, että miten nämä luokat pitää tarkemmin muodostaa, mutta ollaan nyt tässä jo vähän etupellossa liikkeellä, että mennään 3 luokkaan ja idea on aivan sama. Siellä on ne helposti kierrätettävät edullisimpia sekä kuluttaja- että yrityspakkauksissa. Sitten on B-luokka, mikä on kohtalaisesti kierrätettävät, ne on hiukan kalliimpia. Sitten on tämä C-luokka, missä on vaikeasti kierrätettävät tai kierrätyskelvottomat tällä hetkellä. Ja PPWR tuo sitten sen, että kaikki pakkaukset, mitä markkinoille saa laittaa, niin tulisi olla kierrätyskelpoisia. Niin se helpottaa sitten tulevaisuudessa meidänkin työtämme. Eli tällaista luokkaa ensi vuodelle sitten on tarjolla ja katsotaan, miten nämä tässä sitten tulevaisuudessa kehittyy. Hyvä, mennään seuraavaan. Lyhyt muistutus vielä kaikille tästä. Me ollaan jokainen kotitaloudessa lajittelija, mutta toivotaan, että kaikki osallistuisi lajitteluun myös siellä työpaikalla. Sinne on myös omat velvoitteensa erilliskeräyksille, eli silloin kun materiaalia syntyy eri muovi- ja kuitupakkausten osalta 5 kiloa viikossa, tulisi se järjestää sinne myös hallinto- ja palveluja yritystiloihin ja lasilla ja metallilla hiukan alhaisempi 2 kiloa. Mutta tätä saa tehdä vapaaehtoisesti jo, vaikka nuo rajat eivät ylittyisikään, niin aina on mahdollista olla sitten vapaaehtoisesti mukana. Tätä kannustetaan, koska erityisesti muovipakkauksia me ollaan jäljessä meidän kierrätystavoitteista ja talteenotto on vielä niin kuin, aika niin kuin alhaisella tasolla, ollaan alle 50 yrityksillä ehkä aika lailla lähellä sitä, mutta niin kuin, siellä on paljon tehtävää ja toivotaan, että jokainen sitten tätä osaltaan edistää, jotta saadaan materiaali hyvin kiertoon. Hyvä, tässä minun osaltani ja kysymykset otetaan lopussa ja welcome Rickard, it's now your turn, welcome.
Thank you. So my name is Rickard Jansson and I work as a development engineer at Svensk Plaståtervinning or Swedish Plastic Recycling. And our company is owned by the Swedish packaging industry through different federations and associations that are gathering different parts of the value chain of plastic packaging, such as plastic producers and converting industries, and then finally the brand owners that are using packaging for filling into. And we are run as a not-for-profit organization, so any profit that we make would be reinvested in the infrastructure. We were established in Motala in 2018 and has been running a sorting plant there since 2019, and it was also extended in 2023. Now we have the biggest sorting plant in the world for plastic packaging, and we are slightly more than 100 people working here on the site. Just to give a background to plastic packaging and plastics in general, as you know, plastics are used in many different parts of the society. Packaging is the biggest usage of plastic, covering approximately 40% of the plastics that are being used in Europe are being used within packaging. But you also have a lot of different other applications, such as in building and construction, automotive, electrical parts, and so on. But there are different types of plastics that are suitable for different applications, and the most common plastics that are being used in packaging are polyethylene, different grades of polyethylene, polypropylene, polystyrene, and PET, I would say. For some of these plastics, packaging is by far the main usage of that polymer, such as PET, for example, which is more or less only being used in packaging, except for that PET can also be transferred into fibers and can then be used as polyester fiber in the textile industry. But apart from that, PET as a plastic is mainly being used in packaging. For polypropylene, you see that there is a much wider usage of polypropylene in different applications. So it varies depending on the polymer where it is suitable to be used. And when we want to recycle the plastics that we have been using, there are different routes or technologies that can be used for recycling. The most common route today is that we use mechanical recycling, and I will come back to it soon. But there are other ways of recycling at least the carbon within the plastic. Since plastics are mainly hydrocarbon based, there is and the carbon is the interesting element to keep in the loop. There are ways of chemically recycling the carbon and use it in new molecules that are made from this carbon. I will come back soon on the next slide to the differences between chemical recycling and mechanical recycling. But when we use mechanical recycling, typically plastic products are being shredded into flakes, and these flakes are then being washed and remelted into new plastic pellets. And this works well for all thermoplastic based materials, meaning that they can be remelted. There are other plastic types that cannot be mechanically recycled efficiently, and they are thermoset materials. These thermoset materials, they will go through a chemical reaction when you produce the product, and this chemical reaction cannot be you cannot use heat just to remelt the plastic afterwards. So for thermosets, chemical recycling is the dominant recycling method today, if they are getting recycled at all, I would say. But for thermoplastic based materials, which are the typical polyethylene, polypropylene, and PET and so on, they can all be mechanically recycled. And the polymer is more or less intact through this process. If you want to achieve high quality when you recycle the material, it is important that you separate different plastic types and that you decontaminate the plastic. So if you have surface contaminants, for example, you need to remove them from the material before they are being remelted. Otherwise, you will end up with a lot of contaminants within the material after recycling. The positive thing with mechanical recycling is that it uses not too much energy when you remelt it, and that you get a very high process yield. So more or less anything that goes into the granulation step in the extruder where you remelt the material will remain afterwards, except for anything that you filter out, like solids that would be within the material. The negative part or difficult part to handle is when you have plastics that you cannot efficiently separate during the sorting or recycling process, which means that you potentially end up with a mixed polymer material within the pellets, which potentially can give poor mechanical properties of the recycled material. And you also risk to have contaminants or impurities within the material. So anything that you haven't efficiently washed out of the material, potentially chemical products and such, would remain within the material. And you also have the additives that were potentially added to different plastics in the first use phase. Those additives will typically also remain in the recycled plastic. So if you don't have a very good traceability of what kind of material goes into the recycling process, you have a risk to have potentially hazardous additives within the material as well. When it comes to chemical recycling, the polymer will be broken down into smaller molecules. And this can be done through either thermochemical methods, chemical or biochemical reactions. So it's different chemical routes that you can use. The most common chemical reaction process today, which is emerging in the industry, is thermochemical methods. And you might have heard about pyrolysis, which is one type of thermochemical reaction pathway. It means that you heat up the material to a very high temperature and you don't have oxygen present. If you would have oxygen present, the material would ignite and you would get it to burn. But if you remove oxygen so that you have an inert atmosphere where you heat the material, what happens is that some of the bonds within the material will start to break up. And you get reaction products out of this that looks like either natural gas or as crude oil, and the crude oil is typically called pyrolysis oil. And these products can then be used as an feedstock into an already existing chemical process to produce, for example, new virgin-like plastics. But it requires a lot of energy, so you need to first heat the material to a very high temperature, and then after you have formed your products in the chemical reaction, you will only have an intermediate product that you need to process through other chemical reaction ways to produce the virgin-like plastics. And this is very energy intensive compared to mechanical recycling. You also will lose some of the carbon, because you typically don't, when you use a very unspecific reaction way like the thermochemical reaction way, a lot of the end products, the molecules that are being formed, might be of low value for the chemical industry, and then they use it typically as a fuel for running the processes instead. So you lose a lot of the carbon as fossil carbon emissions in this industry. And even if they are often being marketed as a very good recycling for mixed plastics and plastic waste, in the reality, what we see is that they are often sensitive to different plastic blends and contaminations within the plastic waste, because if you have heteroatoms such as nitrogen or oxygen from polymers that are not purely hydrocarbon based, so the purely hydrocarbon based polymers are, for example, polypropylene, polyethylene, and polystyrene. But if you have polyamide or PT, you would bring nitrogen or oxygen also into the process, and these heteroatoms are going to form very low valuable chemical reaction products in the thermochemical reaction pathways. So today, when we talk about recycling from our perspective, we are mainly talking about mechanical recycling. So after we have collected plastic packaging, either from separately collected waste or from plastics that have been sorted from residual waste, this material comes to our sorting center, and we separate them into different plastic fractions. We target to produce mono plastic fractions, so typically pure fractions of polypropylene, polyethylene, and PT, and so on. And these separate fractions can then efficiently be mechanically recycled into valuable materials that can be brought back into the plastic industry. In some cases, it is of very high purity, so it can even go into food contact materials, while in other cases we cannot control all the remaining impurities within the material, and then they are not suitable for that kind of contact sensitive applications like food contact or in other contact sensitive applications. But the majority of what we recycle today goes through mechanical recycling and will become a mono material in the end. We do get sorting rejects, and also in the mechanical recycling process you will end up with some rejected material. So in the sorting process, for example, if you have a multi-material where you have a laminated structure with different layers of different plastics, mechanical recycling will not be able to separate these different layers, and that means that we have if we would mechanically recycle it, it will end up as a low quality material, and there is not always a market demand for these low quality materials, which means that we cannot always get off-takers. Even if we would sort them into a specific fraction, there is not always an off-taker that would accept these laminated structures, and then we get a sorting reject instead. Or there is technically difficulties when you sort the material. For example, if you have black plastics that contain carbon black as the pigment, the carbon black will interfere with our sorting machine so that we cannot clearly distinguish which plastic type it is, and then we would ignore it instead, and it could potentially end up in a sorting reject that we instead send for energy recovery. Within the mechanical recycling process, you typically also will receive some losses. It could be that you have a packaging that contains different components, and these different components can be made of different plastics. For example, you can have a bottle with a cap and a label. All these are packaging materials that goes into the recycling process, but it might only be the plastic type within the bottle that is valuable for the recycler, and then they would separate the label and cap, and potentially they don't recycle all these byproducts that they get from a bottle, and then they instead have a rejected material that goes to energy recovery as well. Looking a few years ahead, you know that the new packaging and packaging waste regulation will soon enter into force, and there are requirements that at least from 2030 will have a great impact to the plastic packaging industry, since it requires that all packaging from 2030 must be recyclable. And that we should be able to recycle at least 55% of the plastic packaging that is put into the market. And we also must use the recycled materials back into similar applications again. So for food contact materials, we should use at least 10% recycled materials. And if they are made of PET, it's even up to 30%. And for other packaging applications, which are not contact sensitive, 35% of recycled materials are expected to be used. And this will require that we focus on high quality recycling. So we make sure that we have a very high quality of the recycled material, where we preserve the original properties of the plastic type, and it doesn't contain impurities that are going to be hazardous for humans to be in contact with. This means that we need to move away from how a lot of recycling works in Europe today, where we instead of keeping the quality of the recycled material, typically downcycle it, due to that we have these mixed polymer fractions or impurities being left in the material, that leads to that we need to find secondary applications for the material. If we mix a lot of the polymers, we will have very poor mechanical properties, which makes the recycled plastic unsuitable to replace virgin plastics in most plastic applications. So instead, the recycling industry must find secondary applications for the material. And in this case, it's illustrated like park benches being put into the society after recycling, and that's due to that a lot of the recycled plastics actually replaces timber and wood in many applications instead. This is one of the typical use cases of poor quality materials, that it replaces wood instead. It doesn't replace the need to produce new virgin plastics. So we would need to continue to produce virgin, typically fossil-based materials for the plastic packaging industry. And after a few years in the sun, these wood materials will be waste, and this waste anyway ends up in waste incineration typically. So high quality recycling, it means instead that we can produce high quality mechanically recycled materials that can replace virgin or virgin based plastics in the plastic industry, or that we use chemical recycling as a complementary recycling technology to bring even higher purity materials into the market. And that's what we try to do at Svensk Plaståtervinning, is to have as many possible outputs as to be able to optimize how we sort the materials for the future market needs. So the Site Zero plant, it covers about Site Zero is what we call our site here in Motala. It is 65,000 square meters sorting plant where we can separate 12 fractions out of the collected plastic packaging waste. It is being done with 60 sorting machines that are based on digital sensors and that can differentiate between different polymers and sort them type by type. We can process up to 200,000 tons of input waste annually in this plant, and it means that we can separate approximately 1,000 packaging units every second in the plant. The materials are being separated into mainly monomaterial-based fractions in the case where it is possible. So if you have designed a mono material, it is a good possibility for us to sort it into these fractions. And we have different fractions of polypropylene and polyethylene, both rigid and flexible fractions. And we have different fractions of PT, where we have, for example, clear transparent PT bottles and colored PT bottles as separate fractions. The same for PT trays, where we have a mono PT fraction, and we can separate polystyrene and so on. You can see here that we even say that we separate PVC, and that is not mainly due to that we want to recycle the material, but we need to get it out of any other fraction, even out of the sorting reject, because PVC contain a lot of chlorine, and if we would leave it in our sorting reject, the chlorine content would produce a lot of hydrochloric acid in the incinerator, which would corrode the incinerator and chimney of the incinerator. So we need to separate PVC, and this PVC fraction that we get out, we will actually put on landfill. So we definitely don't want to see PVC, but it is still the case that in the waste that we receive, we have approximately 1% of PVC in the incoming waste. After we have separated the monomaterial types of plastics, we still have a lot of packaging that weren't designed as monomaterials. So we have these laminated structures, and those laminated structures we wouldn't target for the high quality mono fractions, since they would reduce the value of these fractions. So instead we have decided to separate them out as separate plastic mixes, and we call them polyolefin mixes, and that is that typically at least one layer of these structures are either polyethylene or polypropylene based. So what we have decided to do is that we target anything that contain polyethylene or polypropylene to a certain extent, and then we are very aggressive in the sorting. So we accept that it contains polyamide or PT as separate layers in these structures, to be able to still sort them. So we can detect them by the sensors that we use, and we can separate them from the other mono fractions, but we can also separate them from the remaining reject that we otherwise would get them into. So in our case, we produce two different kinds of these mixes. One is mainly flexible materials, and the other one is rigid materials. And these materials we can process further into an agglomerate on site. This agglomerate we can sell for industries that use it in park bench-like structures or other wood replacement products. So it's becoming these composite products that we want to avoid. And we have avoided it for the monomaterials, but for the multi-layered structures, it's still not possible to mechanically recycle to high quality. So instead we produce these agglomerates that we can sell to such industries that make wood replacement composite products. We are also engaged in chemical recycling projects. So these multi-material agglomerates are also being used in different tests for chemical recycling. So hopefully in the future we can still keep them in the plastic industry as feedstock for virgin plastic production. Looking at how the plant is, how complex the plant is, you can see here our this is the input storage area, and over here is the output storage area. And in between we have a lot of process equipment to separate the different plastics within the incoming waste. So we have first a few steps where we prepare the waste for the plastic separation. So we need to loosen up the material, we need to get some metals out of the material, and we need to have different sizes of materials that are suitable for the next sorting steps. And then in step 7, what we do here is that we separate the film-based materials from the rigid materials. And the films will be processed in this part of the plant, while the rigids are being processed in this part of the plant. And then we use NIR spectroscopy as the technology where we identify the plastic. And here you have 8 machines just being used for the polyethylene film sorting. You have a few machines for the polypropylene separation, and the same for the rigids, where we have also different sorting machines for PT and polystyrene and PVC. And then over here we have the mixed polyolefin sorting. All these materials are being kept in an intermediate storage after they have been separated, so they are being transferred by the conveyor belts into this intermediate storage. And these are bunkers that keep the materials separate. And when a bunker is full, it is being emptied to the baling station, where we get the materials out as bales that are easy to transport to the next recycling process. So as you have now understood, the design of the packaging is essential for the recycling and sorting processes. And in the packaging and packaging waste regulation, there is now criteria that needs to be set up for the recyclability of packaging. So currently we don't know exactly what the criteria will be. They will be published in a delegated act in the end of 27, beginning of 28. So we still have a couple of years ahead where we don't know exactly how a packaging should be designed for recycling. But if you are already using monomaterial packaging, you're in a good position to be also recyclable by the definitions in the packaging and packaging waste regulation. These criteria should take into account that the materials must be sortable and recyclable by state-of-the-art recycling processes. And they should also take into account what is the quality of the recycled materials. We also need to make sure that we have PCR material that can fulfill the recycled content targets in the future plastic packaging. While we are waiting for these final criteria to come, we at Svensk Plaståtervinning is supporting the Recyclas cross-industry initiative that has been organized by Plastic Recyclers Europe, where a lot of design for recycling guidelines is already being published. And on their webpage you can find design for recycling guidelines for typical plastic packaging formats like PET bottles, PET thermoforms, or PET trays, polyethylene films, and so on. So if you go to their website, these are freely available. And as long as you keep it to materials that are within the green lined area here, we can make sure that they are getting recycled. There is currently one part that we can, where we are looking at establishing a recycling pathway, and that is for the colored PET thermoforms that Recyc is publishing guidelines for, but where it is still not an established recycling pathway for it in the industry. But we are working on that material stream as well. But for the other ones, we can already now make sure that the materials are getting properly sorted in our plant and that they will go into a mechanical recycling facility that can efficiently recycle these material back to high quality materials. Looking at the guidelines, they are often very complex when you see them for the first time. They contain a lot of information, and I will not go into the details, which you anyway cannot see on this slide. It's just to illustrate that you have typically 3 columns, and I will come back to those columns, and then you have different rows that specify different constituents or parts of a typical packaging. So for example, there are rows for barrier layers, or rows for caps and lids, or rows for labels, and so on. So you can then find the specific details about what kind of material is suitable to use in a cap on a PET bottle, for example. So when you interpret these guidelines, you should start to look at the green column and try to achieve full compatibility with the recycling process. What is made sure then is that you will have materials that are very suitable to be used in a specific packaging type, and where there is a lot of experience that these materials doesn't lead to problems in the recycling industry or in the sorting facilities. So these materials are typically going to make it possible to keep the materials in a closed loop recycling, such as PET bottles going back into PET bottles, or polyethylene films being suitable to make new films out of. However, you will probably realize that you have some existing features in your packaging designs that are either covered in the orange, yellow, or in the red zone. And you should definitely keep out of the red zone because, or the red column, because these are typically disruptors of the recycling process or the sorting. So these materials either doesn't or they potentially hinders the packaging completely from going into a recycling process, or they will potentially degrade the recycled materials to such extent that the materials are unsuitable to be used in similar applications again. And then you have these materials in the orange column called limited compatibility, meaning that if you use these materials, for example, in a barrier layer, they will not hinder the packaging from getting recycled, but they can potentially lower the quality of the recycled material or lower the yield of the recycling process. And you typically also need to be within specific conditions. So for example, you shouldn't use more than a certain percentage of this material, because then the packaging will be considered to be non-compatible instead with recycling. So and these specific conditions are mentioned in these rows for specific materials. If there are packaging features that you use or materials that you use in the packaging and they are not mentioned in these tables, you shouldn't consider them to be automatically compatible with recycling. What you should do is to think that these can potentially be harmful still for the recycling process, and you should make sure that these materials actually doesn't hinder recycling or potentially degrade the recycled materials. So and this means that they instead needs to be tested, and Recyclas has also made recyclability testing protocols where materials can be systematically tested and evaluated to make sure that they are either fully compatible or limited compatible with the recycling process. So if you don't find the specific material within the table, you should turn to Recyclass and ask them for if they are relevant for testing or not. Looking at the materials that we currently receive, I would consider about 50% of the incoming packaging materials to be well designed for recycling, meaning that we can often keep the materials in similar applications again, or that they potentially at least could be kept in that industry. For example, if we take the polyethylene film transparent, even if they are well designed for recycling, there is currently not there is a limitation still in the infrastructure how they will be sorted and recycled, and often the transparent polyethylene films are being blended with the colored polyethylene films or fully printed polyethylene films, and as you see, these fully printed polyethylene films are considered to be limited recyclability in my perspective, and that leads to a problem. So even if we potentially could recycle them to high quality materials, they are partly going into lower quality grades, and you will see it soon here in the next slides. But for rigid plastics that are up here, they are typically ending up in high quality applications. For example, the clear transparent PET bottles goes back to the bottle industry. While if you are down here in the limited recyclability, it means that often the materials that gets recycled will not end up in the packaging industry. They will be used in other industries instead. And if you are down here on the low or no recyclability, it's very low quality of the recycled materials, meaning that they either go into these composite materials that replace wood, or they are not getting recycled at all. Looking at some of the applications that are being made out of the recycled materials that goes through our processes in the sorting plant, you can see for the polyethylene rigid materials up here, some of it will end up in new packaging bottles, and some will end up like in this bobby car, and at the PET trays, the recycled material will go back into PET trays. For the films, as you see here, we have a mix of both transparent and fully printed materials. These materials today typically end up still in film applications, but in waste bin bags and such. And as you see here, the laminated structures which contain PET and polyamide layers in the polyethylene in combination with polyethylene. In this case, it goes into the agglomerated form that is then going, in this case, into a cable drum that otherwise would be made of wood and not typically plastic based. Looking a few years ahead, as mentioned before, we will probably get chemical recycling as a complementary method. I don't see it as that it will replace mechanical recycling. It just means that we get additional ways of recycling materials that today are not getting recycled. And hopefully this infrastructure is getting implemented across Europe to facilitate in keeping materials in the loop, and we reduce the amount of sorting rejects or rejected materials from the sorting plant or even from the mechanical recycling plant. So materials that today are getting rejected in the mechanical recycling potentially could be good feedstock also for chemical recycling. So what do we as a society need to make sure to packaging or make the plastic packaging a part of the circular economy? We need to efficiently collect the packaging waste. It's definitely preferable to have separate collection of different waste streams. It makes it easier to keep the quality of the recycled materials. But we are also relying on consumer behaviors here, that the consumers must make the work and separate the materials efficiently. And unfortunately, what we see today here, from a Swedish perspective, the collection rate of household plastic packaging waste is less than 50% as separately collected waste, meaning that more than 50% in residual waste streams instead. So this is a very important thing to work on in the next few years. How can we improve the collection from households? We need to have better designed packaging entering the market from the beginning. Otherwise, it will be very difficult to produce high quality recycled materials that are suitable to use in similar applications again. And finally, we need to invest in the high quality recycling infrastructure that is necessary, where we actually do the work to separate the different plastics that are properly designed for recycling, so that we can keep them in the loop in the end. And that was the final slide in my presentation. So I am happy to also answer any question that you have at this moment.
I just checked the chat and we don't have there any questions yet. So if you want to ask, you can also raise your hand and open microphone. Aha, now we have one question. Big bags, fabric PP, does it recycle?
So big bags, in our case here in Motala, our plant is built for household packaging waste, and big bags are not usually being used in as a household packaging. So it's more industrial packaging. They can be recycled as long as you don't blend them with a lot of other materials or any other material. So if you as a consumer in the industry would separate them as a completely separate fractions, and they are not contaminated with hazardous chemicals, they can be recycled back into new fabric materials for polypropylene big bags. But you need to to more or less have the direct contact with a potential recycler for that case. So it's not easy if you today put them in a mixed waste stream, because then they will typically go to an incineration plant instead.
Thank you. And then Raul Hartman, please, you can ask your question.
I would like to add to the first one that aren't big bags more suited for the industrial collection?
Yeah, as mentioned, they can definitely be used as industrial packaging, but not typically in household packaging, no.
Right. Okay, my question was about your process and two things there. I think firstly, the minimum packaging size that you can recognize has been quite large. So
yeah, historically it has been large in many sorting centers. In our case, we go down to 15 millimeter in size, so 1.5 centimeters. So I would say that more or less all packaging that goes into the market is going to be sortable in our facility based on the size.
That's good, yeah. Because I think in previous years it's been like 10 or 15 centimeters.
Yeah, yeah.
And my second question was about the first steps of the process where you ballistically remove very thin film packaging. Are those nowadays being also recycled?
Yes, so in our case, all the films will, even if they are very thin and separated by ballistic separators or wind sifters, they are going to be NIR sorted. So if they are LDP based or polyethylene based, they go into a separate polyethylene fraction, or if they are polypropylene based, they go into polypropylene fraction, and both those fractions will be separately recycled.
That's nice. That's good. So that's also, there's been some development there.
Yes, yes.
Nice. Thank you.
Then we have another question here in chat about mixed plastics, such as plastic with aluminium layer. Do these go to reject and incineration in Finland already, or are they sent to Svensk Plaståtervinning and used as wood replacement materials?
Yeah, so if they are within the separately collected plastics from the Finnish market, they would end up in our sorting plant in Motala. And then it depends a little bit about what is the aluminum layer. So if it is a metallized film, so you can have a very or extremely thin metallized layer where you have by deposition put more or less an atom or 2 atom layers thick aluminum onto a polypropylene film, for example, like the chips bags are typically made this way. The aluminum layer is so thin, so it doesn't impact the quality of the recycled material, and then we will separate them as a polypropylene material and send it to polypropylene recycling. However, if it's a thicker aluminum foil that has been laminated towards another plastic layer, the aluminum layer is too thick to be recycled together with plastics, and today they are rejected in our sorting plant and goes to incineration instead.
Thank you very much. Okay, there's Mari, please ask your question.
Hi, Mari Matson from HK Foods. I have a question regarding nylon.
Yes.
So do you have a statistics of how much nylon do you get in, for example, polyethylene stream right now? What do you do with it? And do you see it as a problem in the future, especially for, well, thinking about products with really sharp edges, and when we're talking about food, let's say we are packing bones. What would you see happening there?
Yeah, I know that currently polyamide is a very important, or nylon is a very important material for these films where you need a high puncture resistance of the film. Today, we don't have that much of experience how they are behaving on the NIR separation. So I think that there is, depending on where the polyamide layer is within the material structure, it can have different impacts to the NIR sorting. So the NIR picks up signals from different layers of the material, but it can only penetrate to a certain extent into the material. So I would say that as long as the polyamide layer is within 50 microns from the surface of the film, we will probably pick up the signal, and then we can potentially separate the polyamide containing films from the pure polyethylene films. And then it's also a concentration, how thick is the polyamide layer and how much of signals does it pick up from the polyamide layer. So I don't have a certain answer to it, but what I have seen in the pellets that are getting produced from our polyethylene stream, it is very little polyamide within that material. There is some, but very little. if we compare to how much of polyamide we have in the mixed polyolefin stream that are made from the films, there is a very much higher concentration of polyamide. So it's 5 times higher maybe in that material stream. So it shows that most of the polyamide containing films probably end up in our mixed polyolefin, but we haven't done any systematic testing to see how it actually behaves on the NIR, because it's often difficult also to make these systematic testing, because you would need to collect materials where you are certain about the material structure, and typically when these materials are put on the market, this is not enclosed with, or the information is not following with the packaging material exactly how is the structure being made, and not even the brand owner that fills the packaging with food knows exactly what is the material structures all the time. So it's sometimes difficult to gather this knowledge and to make systematic testing, but we can make tests. We are a Reciclass recognized sorting line, so we could potentially make tests, but it needs to be well organized, where we systematically collect films with different structures containing polyamide to gather this experience and know how they are getting sorted better in the machines. But I assume that most goes into the mixed polyolefin based on the experience that we have.
Okay, thank you.
Okay, I can answer one question in Finnish. Camilla kysyy tuossa noista meidän POM-luvuista, mikä oli 123 000 tonnia, niin ne on ne, mitä meille raportoidaan, meille ja Sumille yhteensä raportoidaan. Eli se ero tulee siitä, että on yrityksiä, mitkä eivät sitten ole ilmoittautuneet tai liittyneet tuottajayhteisöön, ja ne luvut eivät tule meille raporteille, eli tuo meidän luku on, ketkä maksavat sitten näitä maksuja, ja loppu on sitten semmoista vapaamatkustajaa, niin ero tulee tästä.
Sitten täällä oli vielä toinen kysymys näistä kierrätys- eli keräyspisteistä. Varmaan tarkoitetaan ehkä ekopisteitä, niin siellähän on astioita, usein paperia, pahvia, lasia ja metallia varten, niin kyllähän siellä nyt on jo, jos meillä on noin 1500 ekopistettä, vähän reilu 1500 ekopistettä pakkauksille, niin siellä on noin 1200 pisteessä myös muovipakkausten keräys, että kyllä sieltä löytyy, ja sitten lisäksi kiinteistökohtaista keräystä. I think we had all the questions here. I want to thank you, Rickard, for your fascinating presentation.